Now we're going to do the aromatic hydrocarbons. If you remember, hydrocarbons split into two main groups. The aliphatics, which come in chains and rings. We've done them to death. The alkanes, the alkynes, the alkenes. And then there's a second branch called the aromatics. And we spent forever on the aliphatics. Not going to spend much time on the aromatics at all. Okay, now this is not an aromatic. This is cyclohexane. But aromatic hydrocarbons are based around benzene. Now, there's a couple ways to draw benzene. One of them is every second bond in the ring is a double bond. And there you have it. There are 6 carbons. And counting up the hydrogens, since every carbon in the ring is already bonded 3 times, there's only room for 6 more hydrogens, 1 on each corner. That's a fairly standard way of drawing an aromatic hydrocarbon, a benzene ring. However, things being what they are, there's another way of drawing these, and I don't care which one you use. This one is, for a lot of chemists, the preferred one. So let me clear this first, show you another way. Okay, you draw a cyclohexane. And now, to show the double bonds on every second carbon, you draw a circle. Yeah, just a circle. This looks kind of funky, but so what's with the circle? Well, apparently those double bonds aren't fixed. They're moving all the time, and the circle is supposed to represent that. Or it's supposed to be easier to draw. I don't know. I will accept both. I will use mostly the circle because your textbook uses it. But I'll occasionally revert to the double bond diagram. All right, so how do you name these things? They're actually really easy to name. So let's just do a bunch. Best way to teach you is just to name them. Okay, so what in the world is this? A. Well, I look at that ring. I count 1, 2, 3, 4, 5, 6. I look at the circle, and that's a benzene. So to start with, the naming of the main branch is really, really, really easy. Okay. This is benzene. Okay. Now I have to locate those branches, and you'll notice one is a methyl and one is a propyl. Let's see, I always say methyl first because M comes before P in the alphabet. It's very much like a ring structure. So there's no obvious starting point for carbon 1, but let's call this 1, 2, and 3. And so I'll have, once I pick 1, I'll have to go in clockwise direction. And so this would be 1 methyl, 3 propyl, benzene. That was really easy. I like this. Now, what about B? I'm going to get back to B a little bit later. Okay? What I want to do is work backwards. I'm going to give you a name. I'm going to draw the diagram. Here goes. Okay, whoa, look at this thing. It's actually pretty straightforward. You start over on the right-hand side, benzene. Now, I'll leave it up to you how you want to draw the benzene. Do you want to draw a circle? Do you want to draw double bonds on every second carbon? Circle for me. Okay. And now I have my branches. Diethyl. There's a couple of ways to do this. We almost always draw a line structural diagram for the benzene. It's just too hard to draw all those carbons and hydrogens. But I can put that first ethyl anywhere I want. I can just draw one of those, right? Now that's 1. Now we want to go clockwise or counterclockwise? Yeah, I'm going to go counterclockwise. 1, 2, 3, 4. I'll do it like that. I think it looks funny that way. And there's my methyl. I did it. 1, 4, 2 methyl benzene. Let's do one more way, okay? Just because I want to. Okay, here goes. First, I'm going to start with the benzene, and I think I'm going to go with the double bonds, just to be different. I'm going to show the carbons and hydrogens for the branches. All right. So, okay, the diethyl, that is a carbon, 2 hydrogens, and 3 hydrogens from the second carbon. All right. Let's go clockwise. So it's 1, 2, 3, 4. A little awkward here. I'm going to go CH3, CH2. Some people would do other things with the carbon. And extend that line. Number 2 is going to be a methyl, CH3. There you have it. 2 ways of drawing the same thing. Which one's right? Doesn't matter. Now, I had one more question that I skipped over. Let's go back and look at it. Ooh, B, that's scary. Well, B is a special case. Now, before I go any further, I am not going to test you on B. I'm going to show it to you, and then we're going to forget about it, because we're really shortening this unit quite a bit. Look at that. I have 2 benzene rings. And also, the main branch, 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. And that's actually bigger than a benzene. So there are 2 reasons why this is going to be different than a regular benzene. First off, there's 2 of them. Which one do I start with? Secondly, the branches are actually bigger than the benzenes. So here's what I'm going to do. The benzenes now become the branches. And the main chain, which is 8, becomes all the main chain. So what am I going to call this thing? Starting with the main chain. Octane. It's really simple, right? 1, 2, 3, 4, 5, 6, 7, 8. Now those branches, I haven't taught you this. Let me now show you. These are called phenols. So when a benzene becomes a branch, it becomes a phenyl. So I just write phenyl. All right. There's 2 of them. So anybody want to guess what I do with that? Diphenyl. And now to locate them, well, there's 2 and 3. So it's 2,3 diphenyl octane. Okay, let me repeat my promise. This is part of organic chemistry, but we're really shortening the course quite a bit. We'll be getting some of these questions in the book, but I will not test you on this on the exam, or this exam, or the final exam. Okay? But it's interesting to know. It's also interesting to know that the simple naming structure that we've given you doesn't always work. Okay, so it's very important you do these questions. They get a lot easier at this stage.